Good morning, students. In this video, I am starting the new chapter, that is chapter number 3 of gravitation. Now, in previous chapters, we have learned about the motion of objects, force as the cause of motion. We have learned that the force is needed to change the speed or direction of motion of an object. See, we always observe that an object dropped from a height falls toward the earth. We know that all the planets go around the sun. The moon goes around the earth. In all these cases, there must be some force acting on the objects, the planets, and on the moon. Now, the scientist who was able to grasp that the same force is responsible for all these, and this force was called as gravitational force. And who discovered it? Sir Isaac Newton discovered the gravitational force. So in this chapter, we will learn about gravitation, universal law of gravitation, and we will also discuss motion of object under the influence of gravitational force. We shall also study how weight of body varies from place to place. So the first thing that we are going to start is universal law of gravitation. The first topic of this chapter would be the universal law of gravitation. What is universal law of gravitation? Now, according to it, every body attracts another body. Every object in the universe attracts every other object with a force. There's a force called as gravitational force. According to it, every object attracts every other object with a force which is directly proportional to product of their masses and inversely proportional to square of distance between them. Now, what it means? See, suppose there are two objects. Let us say there are two objects. One is of mass m1 and another is of mass m2, and they are separated by distance. Let us say r, small r. Okay, they are separated by distance r. One has mass m1, and the second object has mass m2. Now, according to universal law of gravitation, every object, suppose this object attracts every other object. This is attracting this object with a force, which will be denoted by F, which is directly proportional to, you make a proportional sign, product of their masses, that is m1 into m2. Also, it tells that F is inversely proportional to, inversely means 1 by 1 divided by, okay, square of distance. Square of distance would be r square between them. So this is the universal law of gravitation, that force is directly proportional to product of their masses. The more the mass, more would be the gravitational force. Less the distance, if distance would be less, force would be more. If distance is more, if these are very far away, the force will become lesser. So this means inversely proportional to square of distance. Now, if you combine both these equations, what you get? You get F is equal to, F is proportional to m1 into m2 divided by r square. And if we remove this proportional sign, we get a constant, and this constant is denoted by capital G, and formula becomes G m1 m2 by r square. And what is this G called? G is called universal gravitational constant. G is called universal gravitational constant, and its value is as it is a constant, it has a constant value, that is 6.67 into 10 to the power minus 11. This is the value of gravitational, universal gravitational constant, and this force is called as gravitational force. And what would be the unit of this? Its unit would be, see how you can calculate unit. If you find the value of g from here, from this formula, what you get? You get f r square divided by m1 m2, right? So how you can find unit? See, f is in Newton, force is in Newton, r is distance in meter square, divided by kg into kg, mass are measured in kgs, so kg into kg, kg square. So this would be the SI unit of gravitational constant, and this formula is the mathematical form of universal law of gravitation.